Okay, on to the third question that we're looking at. So this is exercise 5L. This chapter is all about finding and classifying turning points, more generally stationary points, which would also include a stationary point of inflection. And we're looking at question 3, so I'm going to read it out and just try and write down the key information from the question that I need. So the cubic function, and we've got ax cubed plus bx squared plus cx plus d. So this is the most general cubic function we can ever have. This is just a general cubic function. But we're told that this one has a tangent with equation equals 3x plus 1. Okay, so it's got a tangent with equation 3x plus 1 at the point 0, 0. Sorry, not 0, 0, 0, 1. And it has a turning point at -1, -3. Okay, so it has a turning point. So remember that turning point is a max or a minimum at -1, -3. And we have to find A, B, C, and D from that information. A, B, C, and D. Okay, where on earth do we start with this question? Well, I'm going to start by doing a sketch. I can't do a 100% accurate sketch at this stage because I just don't know what the function is. But I can do something, and something, even if it might be a bit wrong, is better than nothing. So I don't know if A is positive or negative, but I'm going to assume it's positive. So our cubic function looks like this. I might turn out to be wrong, but I need to have something to visualize. Okay. It's going to have a tangent, 3x plus 1. So 3x means it's a positive gradient. So if I'm going to sketch this tangent in, I want it to be here, or I want it to be here. Okay, I think I know that, okay, the other thing is I've got a turning point when x is -1. So either this is x1 or this is x is -1. Either way, x equals 0 is not going to be before it. Okay, because if -1 is here, 0 is up here. If -1 is here, 0 is up here. So I'm just trying to really think this through to do a sketch that at least makes sense with the information that I've got. Okay, so say that I'm going to assume that this is my turning point. I don't know, which means that 0 is somewhere over here. So maybe 0, my positive gradient could look something like this. Right, this could be totally wrong, but I don't know. Right, sorry, that's my cat meowing. Don't get cats, they're very annoying. Okay, right. Now that I've got something just to visualize, I'm going to start doing a bit of work. So we're talking here about a turning point. A turning point has a gradient of 0. Okay, as soon as we see turning point, we should be thinking that the differential function is equal to 0. Here, when I'm talking about a tangent, well, if the tangent has got a gradient of 3, then the differential at that point is 3. So I've got a bit of information here. I know that my turning point is when f dashed of x equals 0. Well, here's the x. So this tells me actually that f dashed of -1 is 0, and this is a very useful fact. If I differentiate this, substitute in -1, I get 0. And here I also know the x point. This is when x is 0, so f dashed of 0 equals 3. This is another really useful fact. So I've got my diagram, but I'm going to work algebraically going forward. So let's differentiate this. I've just realised that we were actually given it as p, and I've changed my notation to f. Never mind, we'll cope with it. So differentiating 3a squared plus 2b, sorry, I got that wrong, 3ax squared. That is an important mistake to pick up here, plus 2bx plus c. All right, and now I'm going to substitute both of these key facts in. So if I use fact number 1, I get that, well, f dashed of 0 is going to be 0 plus 0 plus c. So 0 plus 0 plus c is 3. Well, that was nice and easy. I found c. It's a good start. Now let's see what happens if we use fact 2. So I've got that f dashed of minus 1 is 0. So minus 1 squared is 1. So that term is 3a. That becomes minus 2b, and I'm going to use this fact. I know that c is 3 now, and that is 0. So this does not enable me to find a or b, but at least I've got some kind of connection between them. Okay, what other information is given to me then? Because I've got a connection between a and b, I've found c, which is fab. I still don't know anything about d. Generally speaking, if we have 4 unknowns, a, b, c, and d, we need to use 4 facts. And it's just occurred to me that I've overlooked 2 very simple facts. I've been given a pair of coordinates that fit on here. I know that when x is 0, y or p or f or whatever you're calling it is 1. So this here tells me that f of 0 equals 1. Okay, here's fact number 3. And similarly, this tells me that f of negative 1 equals negative 3. So these 2 facts are the original function, the other 2 are the differentiated function. All right, so this is fact number 4. Let's use them. So using fact 3, I get f of 0 equals 1. Well, f of 0, I'm just going to copy f down here. I'm just sticking by calling it f for now. I don't care that it was called p originally. I'll put p in my final answer, but for now I'm just going to use this. So when x is 0, 0 plus 0 plus 0 plus d. Great. So d is 1. Thanks very much, fact 3. That was nice and easy. Hopefully, I'm going to get some sort of combination involving a or b in this last one, and it's going to mean that I can figure out all the rest. So using fact 4, f of negative 1 equals 3. Okay, negative 1 cubed is negative 1, so this is minus a. Negative 1 squared is 1. C is 3, and x is negative 1, so that's minus 3, and then d is 1. And that answer is negative 3. So let's simplify that. I get minus a plus b plus 1 equals 0. Okay, and I might just simplify that even further and say, okay, that means a is b plus 1. All right, so I've got a connection between a and b here. I've got a connection between a and b here. It's not done, but I can solve these 2 as simultaneous equations. Solve simultaneously. Okay, and remember we can solve equations simultaneously by substituting one into the other or by eliminating one. So with the format we've got, I'm going to go for a substitution. I'm going to simply say, well, I know what a is in terms of b, so I'm going to put this, instead of 3a, I'm going to write 3b plus 1. Minus 2b plus 3 is 0. So here I'm substituting the fact that a equals b plus 1 into my kind of fact 2 line. 3b plus 3 minus 2b plus 3 equals 0. b equals negative 6. Okay, and finally that means that a equals negative 5. All right, so I think I've got my final answer. Negative 5x cubed minus 6x squared plus 3x plus 1. I wouldn't just stop there and accept that. I'm going to find a way to actually check whether this is correct. And the way I'm going to check is using my calculator. I'm going to pop this in, menu, I want to do a graph. So I'm going to say negative 5x cubed minus 6x squared plus 3x plus 1. Okay, I'm going to draw it out. So actually my original little sketch was wrong because we've got it going the other way. I can't see an awful lot here. What I'm going to do to help me with this is just use my trace button. First, I'm going to say I don't need to see that much up. I'd like to see a little bit more down. And let's draw it. Invalid setting. What have I done? Right, I just had a bit of a play around on my calculator. I've done something to it, so I can't draw it. I need to figure out what, but in the meantime, I did check the answers in the book, which obviously you can't normally do, and this is right, so we're done.